Unit 2 in computer architecture is arithmetic for computers. So the first topic is ALU. ALU is responsible for performing arithmetic operation, addition, subtractions, multiplication, division and logical operations such as AND, OR and NOT. They are performed based on the data type. There are two data types, fixed point number and a floating point number. Fixed point number in the sense it can be a positive or a negative number. The floating point number in the sense combining both the integer point as well as a fractional point. So for that it will follow either a big Indian or a little Indian format. The big Indian in the sense when a lower byte addresses are used for a most significant bytes. The most significant bytes are in the lower byte address. The least significant bytes are upper significant bytes. The little Indian is a vice versa of a big Indian when the lower byte addresses are specified in a less significant bit and the most significant bit are being placed in the first part of the byte address. Fixed point representation which uses both the signed number as well as an unsigned number that are all being given as an input to ALU. One's complement representation. So one's complement in the sense the zeros are complemented to 1 and the 1 is complemented to zeros. The 2's complement as 1 complement value is added with the 1 when we'll be getting a final answer is a 2's complement representation of a given numbers. Now we can performing addition operation. Add in the sense first one is 4 minus of minus 5, so it is become 4 plus 5. So you can directly perform the addition operation. The next value is 6 plus minus 5. Here only one negative number, so you can performing a subtraction operation. Here the different combinations of addition and subtractions. Simple addition, binary addition, 0 plus 0 equal to 0, 1 plus 0 equal to 1, 0 plus 1 equal to 1, 1 plus 1 equal to 10, 1 plus 1 plus 1 equal to 11. So this is a simple addition operation of two-digit number. First number is a 6 number that is converted into a binary number followed by the 7. That decimal number is converted into a binary number. Now you can performing the addition with the two binary numbers. The half adder is a combination circuit which perform the two binary addition operation is also called as half adders. It can performing a 3-bit addition in the sense that is called it as a full adder. The half adder truth table followed by the logical representation. You needed to give two inputs, value of A and B. It is given to the input of a half adder. It will be produces the sum and carry value. This is similar like a table. So you needed to draw a K-map based on the sum and carry value. So here the AND gate, the input of A and B, you will be getting a carry value. That carry value is A and B. So here the A and B, A, B only one state in the sense you will be added with getting 1, 0. 0 is a sum, 1 is a carry. So this is a logical diagram of an half adder. The first XOR gate which produces a sum value and the AND gate which provided a carry value. The full adder in the sense the 3-bit adder, you needed to give a 3 values as an input A, B, C and it will be produces a 2 outputs. What will be the output in the sense it will produces a carry value and a sum value. So this is a truth table of 3 full adders which is similar to the half adder. The half adder we are giving 2 input data. So full adder you needed to give a 3 values as an input and it will produces the same as a half adder. It will produces a 2 values. One is sum and carry. So this is a K-map and this is a logical diagram of full adder. Next one is a subtraction. The subtraction in the sense 0 minus 0 equal to 0, 1 minus 0 equal to 1, 1 minus 1 equal to 0, 0 minus 1 in the sense you will be getting 1 and another one value, borrowed value 1. So your borrow value becomes 1. So this is a simple division 0, 0, 0. So here 0, so you needed to get a borrow value 10, 10 minus 1, 1, so you already give it to some other places, so here becomes 0, 0 minus 0, 0. Likewise, you need to do all these bits with the help of the above truth table. So if they given us a decimal number, in the sense you needed to first convert that decimal number into a binary number. After the conversion, you may directly apply a subtraction. Before that, you needed to convert the given number into a 2's complement number, the 15. You will get this 15 into a 2's complement number. You directly add it with the 28. The final answer will be the answer of the above sum. Next is a multiplication, the sequential multiplication of a positive number. So this is normal multiplications. Another one is a flowchart method. So you needed to check the Q0 value every sequence. If the Q0 value 1, in the sense you needed to perform addition operation. Otherwise, you are directly perform the shifting operation. So these steps are being repeated until the count value becomes 0. If it is 0, in the sense the multiplication process is completed, you will be getting a final product with a A value and a Q value. This is a Booth multiplication. For this, you needed to check Q0 and Q minus 1 value. If the Q0 and Q minus 1 value becomes 1, 0, in the sense you needed to perform the subtraction. If it is 0, 1, in the sense you needed to perform the addition. So after the completion, if it is 1, 1 or a 0, 0, means you can directly perform the shifting operation. These steps are being repeatedly done until reaches the final step. If the count value becomes 0, in the sense the process get to be completed. The multiplication completed, you will be getting a product value. The bit pair multiplication recoding, you needed to pair 2 bits. 0, 0, it becomes 0, 0, 0, 1, 1, 0, in the sense 0, 1, 0 becomes 1, 1, 1, 0. So these are all the multiplication table. Final one is a division. So you needed to first the dividend and divisor value. This is a normal division process, or you may follow the flowchart. So first of all, you needed to set A value 0, B is your divisor, Q is the dividend, and count is the number of bits are being presented in both dividend and divisor. First, you need to shift the A and Q value. Next one, you subtract A value with the B value. You needed to check the A is less than 0 or greater than 0. If it is less than 0, in the sense you change the Q0 value to 1. Otherwise, you needed to perform the addition operation. For after completion of the operation, the counter value get to be decreased. When it is becomes 0, the final process is completed, you will be getting a quotient value and a reminders value. Floating point representation. The floating point values are being evaluated with the help of sign notation, Mantis's, and scaling factor. The topmost value is an exponent. See, that's all about the operations of ALU. Thank you.